You can use Godot resources to connect different pieces of your code or scenes together without direct dependence on the node hierarchy. And we're going to be doing it with C#. And I'm going to show you guys an event bus pattern so that you can connect what happens on the player to what gets shown on a player log through events that are connected through those Godot resources. Okay, so here's the simple example. We have a player placeholder, and we want it to have a script that can show what movements occur on the player log when key presses are occurring on the player. So for our starting point, I'm going to attach a new C# script to the player here. And in your top right, if you don't see this build project button, just make sure that you've created a new solution here in this menu, C# create solution, and that'll allow you to build the project. So for the player node, let's add in a new script. So this is going to be using the template character body 2D. Make sure that for language you choose C#. Let's create that. And obviously C# code doesn't edit well inside of the Godot editor. So I'm going to jump right into Visual Studio Code, where we can take a look at this same script and everything's color-coded. It's a lot nicer. So the default script is set up for a platformer. So to remove that jump and gravity components, I'm going to get this part here. We don't need gravity because I'm doing a top-down demo, and we don't need jump for now for the same reasons. So then what we're left with is up, left, right, down, move directions. And when we let go of the key press, our velocity moves towards 0 and basically the character stops. Okay, so let's go ahead and make sure that this script works inside of the game. So I'm going to go into game mode. Okay, so let's go ahead and launch the game. And I think those key presses are up, down, left, right. So left and right work, and up and down don't, because I guess it's a platformer controller. So we can fix that real quick. So rather than velocity x, we're going to just do both the x and y at the same time here. So velocity is actually going to equal a new vector2, and that'll be the direction x times speed, and the direction y times speed. Okay, and we remove this line, and then same thing down here, basically. We want to set the whole velocity. Yeah, velocity move towards 0 with speed. That should work fine. Okay, now if we go back, make sure everything compiles, hit play, we'll be able to up, down, left, right move. So it's basic top-down controls now. Okay, so now we want the player log to be able to pick up on what the player is doing, and then have it logged to this panel down here. So in order to do that, we need a way to share the context between those objects. Now, if I look at the game scene, you can see in the hierarchy that the world contains the player, obviously, but unless I right-click here and do editable children, like these weird editor hacks, then I can't directly assign the player to the player log, which would be needed if we did like a @export node reference, right? A better way, in most cases, is going to be to use resources. So I'm going to remove editable children right there. Okay, and then let's Alt-tab back into the C# editor. Okay, so in our IDE, let's create a new folder. I'll just call it resources. And then let's right-click, do a new file, and we'll say playercontext.cs. Okay, and this is going to need Godot, probably system as well. And then we'll say public partial class player context, and it's a resource, not a node. That's very important. Let's expand that. And now there's a couple approaches you can use at this point. One would be that the player sets its own reference inside of the player context, and then anything with a reference to the resource would be able to get a direct reference to the player. But the approach I'm going to go with here is putting events into the player context. So the player will call those events when things happen to the player, and then anything else can connect to the events within the player context in order to receive the data only when it's relevant, like when something actually happens to the player. And I'm going to put the events directly in the player context for simplicity, so that you don't have to find nested objects within the player context. We can just connect right here, which is simpler. So let's create events. We could add a player death event. That would definitely be useful later on. But for right now, let's say public event action. I'm going to pass in vector2. And then for the event, I'll say player input. Yeah, let's say direction changed. Okay. So this is an action that's going to take a vector2 as a parameter. That's the input direction. Every time we call on the event, we need to pass in the current direction for the player's input. And then anything else can respond to that with their connection. Now I'm using C# events instead of Godot signals. If you wanted to, you could go this way, which would support GD script connection as well. But if you're doing pure C#, technically events are faster. Not that it matters too much. But yeah, that's all we really need there for now. But now in the player, we're going to need a reference to that player context. So we can come over here and do this, export, and we'll have a public player context, get set. And this allows us to add the player context in the inspector. So we can literally assign a file to the player. It doesn't have to exist within the same scene because it's a file inside of your project. And that's really a huge distinguishing point between resources and nodes. Nodes have a hierarchy of the nodes. They have to exist in the same scene to reference them directly anyway. And then resources exist in your file project. You can reference them from any of your scenes, and it allows you to connect things, to wire things cross scene. All right, let's jump back to the Godot editor and compile. Make sure that we can put our reference up there. So recompile, and you should see a field for context. But if I click over here, you can see that it allows you to assign any resource, which is not what we're looking for. So I actually forgot to put up here that this needs to be a global class. So now we recompile, and it should understand exactly what we're looking for, since that actually registers this inside of Godot. It's not just a C# type anymore, it's a registered Godot type. Okay, so that makes it much easier to assign the correct one. We have the player context, and we want to assign this over to the player log as well. So what we do is we right-click here, save as. Yeah, sure, we can go into resources, and let's say player_context.tres. That's the extension for resource. Save it. Now we want to go over to the player log, so we'll have to assign a script here as well. Let's attach a new script, player log CS. That looks good, except that it's not a node. Okay, we create. And of course, I want to edit that in an IDE, not directly in Godot. So I have our player log over here. Let's add in export for player context, save that, go over to the editor, compile, and we're going to assign the same player context. So you can click here, do a quick load, find the same context in the project, save it, and now you can see that the player log and the player are wired up, sharing the same context, even though they're in completely different scenes. That's not possible with an export node path reference. So now we have the event inside of this context. We can wire that up in the player log. So let's say on ready, we'll do the context. And actually, I guess context is an okay name there. Since it's a player log, the player part is implied. So do context.the event and wire that up to a callback, kind of like that. Of course, we don't have this yet, so we have to write that. We're not going to be doing any process function in our log. That's a little silly. So let's create that function. I'll hit tab to autocomplete this for now. That's definitely not how we're going to do it in the end, but this is good for demonstrating at least. Now let's go back to player, and we need to make sure that the event actually gets emitted. Now, if I haven't mentioned already, physics process is going to run 60 times a second. So if I send out the events this time, it means it's going to be 60 logs per second, which is a pretty terrible practice. But we can use it just for demonstration and then go from there. Okay, one other thing I forgot here is that since I labeled the action as an event, the function that calls it has to basically go in here in the player context. So yeah, we'll have a notify event, and we can call this function from our player. So notify player input direction changed. We pass in the vector 2. That's going to invoke the event. This question mark right here just means that if there's no subscribers to this action event, it's going to skip over it because there's no need to notify if no one's subscribing. Okay, so now back in player, whenever the direction changes, we can call that notify event. So we'll do context.notify player input direction change, pass in the direction, and that should work just fine. Now, as it's going right now, this means that the direction is going to be passed in here for a event notification, even if it's still the same value as before, which is not a good practice. It's not good to put it in physics process either, but this will work. And then we'll see a huge spam of logging to the console. Now in the player log, we've already connected to that event, so that's good. If we go ahead and recompile our project, we should be able to watch the output log and see the event spam occur, even when we're not pressing. And you can see right there, that's exactly what's happening. I'm not pressing anything on the keyboard, but it's saying player input direction change. if I move around, then you do see that it is showing the correct values, but it's spamming an unnecessary amount of log messages. And FYI, these messages are pretty expensive and completely unnecessary. So a much better way, for starters, would be to actually see if the value has changed. So let's do a private vector to, let's say, last input direction. Yeah. And we'll default that to vector 2. So basically, whenever we get to this part where we're considering if we should notify that the direction changed, we first want to check if the direction has changed. If not, then we skip over that. And we want to make sure that the last input direction gets set. And we only need to change the input direction if the new one is actually different. So this is actually better than putting it down here, though both approaches pretty valid. Okay, so we're going to get a lot less messages to the console and the player log. So let's hit play. We'll hit compile and play, of course. And now we move around, and you can see it only actually reports when it actually has changed. So that in itself is leagues better. So the next thing we should work on is making the player log report here rather than to the console, so you can actually see what's occurring in game. You want to log every event to an in-game log. This is probably a bad example, but to show how you can do it, we'll do that. Player death would probably be a great one to log to an in-game log, just as an example. So let's see. We need a rich text label down here, and then let's put in some test content. Okay, just make sure that's okay. And we won't worry too much about the formatting here. I will add in a margin container above it. So add a margin container, rich text label goes into there. We take the margin container, and either in your theme or just overrides, we want to add a little bit of margin. Probably more than that. I'll do 5 pixels. And that just keeps your text off the edges of your panel. Okay. Then we need a reference to the rich text label. Now in this case, using either a get node or an export variable onto a node reference is fine, because those nodes are guaranteed to be existing under the UI element itself. So it's really a bigger part of the UI, and we're just containing it in a script up here to handle the logic. In the player log, so you have a couple options. You could do export rich text label, and then this would be more like the, let's see, I guess I would call it more like the log output, right? And then of course you would want to add the new lines of text whenever the event happens. Then you can remove this, right? So that works. Another option, you could skip the export, or as a fallback, you could do something like if log output is null. Yeah, curly brace is not colon, it's not GDScript. Then we find the node of type rich text label with the name, whatever we assign to it. And then if that's still null, we could throw an error. So yeah, roughly like that. So this is like a nice fallback, right? But you can, of course, assign a manual node path with that export in the editor. And then it'll just fall back to finding the node with log output if you failed to assign that directly. Of course, you only need one, but you know, 2's not bad. So we'll assign the rich text label. Probably should call it log output to be consistent with what the script says. Okay. And now we can, I think, go ahead and run. It must have already auto-compiled because log output's right there. So let's hit play, and let's see if that's triggering as we need it to be. Up, down, left, right. Yep, there we go. We have in-game logging events through that context resource. Now, I'd probably clear out the default text here. So if you do want to keep the placeholder for whatever reason, you could do like log output.text equals an empty string, save it, compile, and run that. And then that'll make sure it's clean whenever you come out here. The event's also a little bit verbose. So I would just say like player direction. That's going to make the output a little bit cleaner, get everything to show on one line. Okay, so let's show one more event that we could log through our player context. So as I mentioned, it might be a cool idea to do something like public event action player death event. And that doesn't need any parameters. So then we'll just need a notify for the player death. I think this comment really belongs more like up here. Let's move that. And then now we have this player death event. So we can just set like a timer on the player so that it's going to let us know when the player dies. So actually, let's do a public int health. Yeah. Or even make that an export property. So really when it comes to stats, I'd probably move this into a separate C# script eventually, but this is okay for the tutorial. Okay, so let's make this event work. Okay, so down here, I'm gonna create a take damage function, which basically means whatever value gets passed in here, we subtract that from the health, and then we call the events and the actions on this node as we need to remove the player from the scene. I think you would usually play a death animation here rather than just queue free right away, but this works for now. Let's say that whenever the character puts in a new input, that's when we take damage. Okay, take damage 10. And we can also add one more event, which is that the player health changed. So let's add in public event action, let's say integer, player health changed. We'll put in that notify as well. Go over to the player, and we'll add that in here. Whenever we take damage, we'll just do the player health changed. You could have an extra check here that if the damage is 0, just return. Yeah, sure, that makes sense actually. So I'll say if damage is less than or equal to 0, then we'll just return. Oh, need a parentheses there. All right, looking good. So whenever we do import on the player, it's going to take 10 damage, and he has 100 health by default. I'll move this export up here as well. And we go back to the main project, and we'll hit play. So we can see health is 100 here. Now we're going to hit play, and we're going to get all of these events to trigger. So I press up once. Oh, no. Yeah, because we didn't subscribe on the player log, right? So the player log needs to subscribe to the other events. Player health changed. Okay. So you can see the autocomplete is suggesting a lambda expression. If all you need to do is set the text, then that is a pretty okay way of doing it as well. I'm going to keep it explicit here. So I'll say on player health changed. That just means instead of inlining everything, we actually have a full function declaration down here. Though they would both work the same. So, yep, I'll just auto tab that. We get the on player health changed and the player death. So now it's going to report all the events to the log. And we can go back in here, hit play, and let's move around up. And you can see immediately that we get player health down to 90 and then down to 80. So because I pressed up and let go of up, that triggered 2 events there. So health goes down 20, and I can press around, and eventually we get to player has died. So we get all of this event communication without needing to have a direct reference between the player and the player log, your UI HUD, your player, your objects in the game. Hopefully in this video, I've demonstrated some of the use of using resources in Godot. Also, we've got like a signal bus pattern going on here. I didn't nest the events here into a separate explicit bus just because it's unnecessary at this point. But you could totally do like a player event bus, and then in this other class, you would put all of the events in there. The player would connect to there for sending events, and then your log would connect to this for receiving events. But you can see that's just another layer of abstraction. And since this is just doing this one thing right now, it's not needed. As you get more stats, you could also pull this out to a separate object as well. And that's something I would definitely do. One thing I forgot to mention earlier is that we're subscribing to events, but I never unsubscribed from those events. So when the player log disappears from the screen, we want to ensure that these events don't trigger for this player log connection that no longer exists. So what I should be doing is, yeah, exactly this. On exit tree, when the player log leaves the scene, as in it's pretty much no longer going to be used in the game because we're removing it for whatever reason,